This chapter is real numbers for standard 10, and this is a continuation of a series. This is part 5. So now here we are going to learn a new theorem, fundamental theorem of arithmetic. It's also called as FTA. So here every composite number can be expressed or factorized as a product of primes, and this factorization is unique except for the order in which the prime factor occur. For example, you take a number 48. You can write 48 as 2 into 24. Further, you can again write it in this 12 into 4 or 16 into 3 or 8 into 6 and so on. But you have to know, as per the FTA, we have to factorize it as a product of primes. So these are all composite numbers: 16, 8, 12, 4, 24 are all composite numbers. So we will again convert it into, we will write a product of only the primes. So when you write, you get 2 to the power of 4 into 3. So 2 is a prime and 3 is a prime. So we can write only in this. There is no, you cannot write in any other way except this. Here you were able to write, but here apart from this, because you are writing it as product of primes, only maximum you can write it as, instead of 2 to the power of 4 into 3, you can write it as 3 into 2 to the power of 4. The value is not changing, because commutative property of multiplication. So that's what this factorization is unique except for the order in which the prime factor occur. So this will help us to, when we do the next problem, we will understand the importance of this uniqueness. So prove that there is no natural number for which 4 to the power of n ends with the digit 0. So let us write 4 to the power of n, factorize it as the product of primes and write. So it is 4 is 2 squared, the whole to the power of n. So this is a to the power of m into whole to the power of n is a to the power of m into n, laws of exponents. So 2 to the power of 2n. Now this is the only way. Now we have written this as factorized to the primes. So there is no other way of writing this. So you have only 2 as a prime factor. So you have to write by uniqueness of FTA. The only way 4 to the power of n can be expressed is 2 to the power of 2n. But here they have told, we have to find whether this can end with the digit 0. For any number to end with 0, you should always have 2 and 5 as the factors in that number. So because 2 into 5 will be 10. You can have other factors also, but definitely you should have a factor 2 and 5 for any number to end with 0. But we have only 2 here, we do not have 5. So the number cannot end with 0. For any number to end with 0, it should have 2 and 5 as factors along with other factors. Since this does not have 5 as a factor, the number cannot end with the digit 0. Show that 12 to the power of n cannot end with digit 0 or 5 for any natural number n. It's also similar to the previous problem, but here we have to prove it does not end with 5 also. The previous problem we did only with, it cannot end with the digit 0. So here for 5. So at first we will write, factorize this number 2 as product of prime factors. So you will get 12 to the power of n as 2 squared into 3, 4 into 3, 12. So 2 to the power of 2n into 3 to the power of n. So you have to write by uniqueness of FTA, 12 to the power of n can be written, can be expressed only as 2 to the power of 2n into 3 to the power of n. Now for a number to end with 0, it should have 2 and 5 as factors, which we discussed in the previous problem. It does not have 5 as a factor, so it cannot end with 0. Now coming to ending with 5. So if you see any number to end with 5, you should have 5 as a factor, but you should not have 2 as a factor. But because if you have 2 and 5 as factors, then it will end with 0. But to end with 0 compulsorily, to end with 5 compulsorily, it should have 5 as one of the factors. So here if you see, you don't have 5 as the factor, but you have 2 as the factor. So it cannot end in and end in 5. So for a number to end with 5, it should have 5 as one of the factor, but should not have 2 as its factor. But 12 to the power of n has 2 as factor and does not have 5 as a factor. So, it cannot end in the digit 5. Now, explain why 3 into 5 into 7 plus 7 is a composite number. So, composite number is a prime number is a number where you have factors 1 and the number itself. You do not have any other factors in prime. For example, you take 13, you have 1 into 13. You have 7, 1 into 7. 23, it is only 1 into 23. You do not have any other numbers apart from 1 and 23, 1 and the number itself. That is why those numbers are called prime numbers. All other numbers are composite numbers. That means it will have other factors apart from the number and 1. So, we will first see whether you can write it as product of other composite numbers. Product of other numbers apart from the number and 1. So, 7 is a common factor in both. So, 7 taken out. So, you get 15 plus 1, get 7 into 16. So, you have another number 16. 16 is a composite number. So, the whole number is a composite number.